This recording is about the Casio FX991ES calculator. On screen you can see a Casio calculator. This is an FX85 variant, commonly sold for students at GCSE and certainly A level. When you look on the calculator, you will see on the mode button you have 4 modes. This particular model isn't as good as the one I want to look at because it doesn't have the number of modes that the 991ES has. That has 8 modes and this only has 4. The reason I'm looking at this calculator is to show those of you with this type how to do simple complex number conversions. So, for example, if I wanted to convert the number 3 plus J4, a rectangular complex number, into 5 at 53.13 degrees, which is what it should come out as, I would have to go from a rectangular to a polar number. So on this calculator I have a key here with a shift function labelled pole. This means I want to go into polar from rectangular. So start off saying shift pole, I'd enter 3, and then I need a comma just here, so that's shift comma and 4, close the bracket and press equals. I now see my answer as 5 at 53.13 degrees. This calculator will only perform conversions. It will not add, subtract, divide or multiply complex numbers. If I wanted to do the reverse process, that is, I want to go from polar to rectangular, on the keyboard I look for the rec symbol, meaning rectangular. So I'm going into rectangular, shift rec, I'm putting 5, comma, shift comma, 53.13. This is only approximate, so it's not going to come out exactly right. Okay, press equals, and I can see X is 3 approximately, and my Y value, I can move along the screen like this, giving me Y is virtually 4. Okay, that's the FX85, and that's purely conversions. If I now change to the FX991ES, we'll just close this one down, and we're going to go to the Casio. And this is an electronic emulator, of course, but works just like a normal Casio calculator. This is the 991ES variant. You'll see on the screen, first of all, it shows a D for degrees. If it's not showing degrees, you can make it show degrees by going shift mode and looking for degrees, which is 3. The other choice is radians particularly, so making sure it says 3 for degrees. I want to work in complex number mode on this one, so here on mode I want 2, which is complex, so choose 2. If I want to enter a complex number now, I have to remember this calculator is built for engineering, or rather I should say maths generally, not engineering. So when I look at my number on the screen written as 3 plus J4, I'm going to have to enter this number as 3 plus 4I. So the I represents the J, and it has to go second. So on the calculator, bracket to begin with, which is the best way to make sure you don't make any errors with complex numbers. 3 plus 4I. Okay, the I is on the eng key. When in complex mode, the eng function doesn't work. Close the bracket, press equals, the calculator accepts it. If I want to convert that into polar, I look for shift on the second key, which has a complex menu. So shift complex, I want to choose 3 to go into r theta, I now press equals. 5 at 53.13 degrees. If I want to show that on 2 lines, I press S to D, and that will help me see a bigger number. S to D meaning third to decimal. Okay, if I want to do the reverse process, I would enter, again using brackets for safety, 5, and the angle symbol is here. It's a shift function, shift angle 53.13, close bracket, press equals. Now the calculator all is set to default to rectangular form. S to D to put it on 2 lines. That is my 3 plus J4 effectively. I didn't need to do a particular conversion for that. So if I now want to look at some other calculation, let's say I want to multiply 2 complex numbers together, this calculator will do it. 5 plus 10i, close bracket, times, second bracket, 3 minus 2i. Remembering that I have to go second, otherwise the calculator will generate an error message. I now get my answer. If I want to see that in polar form, again, shift 2, 3 for polar, and equals. I get a third form answer on 1 line. S to D gives me a decimal form answer on 2 lines. You can do, of course, division. If I wanted to divide the 2 numbers shown, I would use my fraction key and put, without brackets this time, because this is the fraction line separates the 2 complex numbers nicely, plus 12i, 2 plus 3i, press equals. I've got a third form answer, which on 2 lines in decimal looks like that. If I was multiplying more than 1 complex number in the numerator or denominator, I would certainly have to use brackets in the fraction form. Okay. If I wanted to multiply 2 polar complex numbers together, works in just the same way. 2 angle 40 times 3 angle 10 equals, again defaulting to rectangular form. If I want the answer in polar, shift 2, 3 equals 6 at 50. And of course I can do division as well in the same way. Use a fraction, 24, shift angle 60, divided by 9 at 20. Rectangular form answer, convert to polar if required, 8/3 at 40 or 2 2/3 at 40. Okay, that is working with both types of complex number, but if I want to do a mixed calculation, that's perfectly feasible as well. So here 3 plus 4i times 9 at minus 30 gives me that as an answer, a third form answer. If I want it in rectangular form, that's the decimal version, or shift 2, 3 gives me the polar version. So as you can see, this calculator is extremely useful if you have coursework or even exam problems. You can check your answers with the calculator to ensure you're getting the right answer before you set out a full form answer. I recommend this calculator to engineering students constantly because it has not just complex number mode. If you'd like to I'll come to the mode button. You'll see it has 8 modes there. Complex number mode is number 2. Statistical, it has base n operations, you can convert between number bases. It has equation solving operations in 5. It has matrix operations available in 6. Table function in 7 for generating tables of results from polynomials, for instance, and a vector mode 8. All of those modes will be useful to you in maths, in engineering. At a price of under £20, this is a bargain calculator that is of enormous help in engineering. I commend it to you. Thank you.